So what happens when we want to use elimination to solve a system of equations, but our coefficients are not the same or opposite either for x or y, thus not allowing us to directly add or subtract? Well, we can make use of multiplication as a way of forcing those coefficients to become the same or opposite so that we can get to the point of adding or subtracting. So with the system of equations you see here, you notice the coefficients for x are 3 and 5. The coefficients for y are 4 and 2, so we're not in an ideal situation where we are ready just to straight up add or subtract. But we can multiply one or both of the equations as needed to force those coefficients to become the same or opposites based on essentially recognizing what the least common multiple is and multiplying one or both equations as needed to achieve that least common multiple so that we are then in a position to use addition or subtraction to finish solving by elimination. So with a little bit of advanced scouting here, you can see that with our coefficients of x being 3 and 5, my least common multiple would be 15. So I'd have to multiply both equations, the top by 5 to make the top 15x, and the bottom by 3 to make the bottom 15x. Or maybe more efficiently, I can focus on the coefficients of y and their least common multiple being 4, which would allow me to only have to, or require me only to have to multiply the bottom equation by 2, which will force that bottom coefficient for y to become 4, equal with the coefficient of y up above 4 as well. And then I'll just be able to add or subtract as need be. So that's the method that I'm going to choose. So I chose to eliminate y with a little bit of advanced scouting. I'll multiply the bottom by 2 to get to the point where the coefficients are equal. And then because they're equal, or they're the same value, I'll know that I will need to subtract accordingly to continue with substitution as I know it. So let's start with that process. I'll start by rewriting the top equation, 3x plus 4y is equal to 6. I will multiply the bottom equation by 2, being sure to distribute that 2 to all three terms along the way. So 2 times 5x is 10x, plus 2 times 2y is plus 4y, is equal to 2 times negative 4 is negative 8. And here's this position I want to be in, where my coefficients are now the same. And I can just proceed with subtracting the two equations, eliminating my y term as a result. And you'll see with 3x minus 10x, I get negative 7x. 4y minus 4y, there's the elimination we just referenced. 6 minus negative 8, being careful with the signs, would be equal to 14. And then just solving this out for x by dividing both sides by negative 7, we're at the halfway point of x equals negative 2. Now from here, it's just a simple matter of taking that known value for x in this case, substituting it into one of my two original equations, and finishing up solving for y. So I'm going to just choose the top equation. It seems like the computations are a little less complicated. So notice I'm just rewriting the top equation, but where x would be, I'm substituting with negative 2. And I'll continue with my work from there. So 3 times negative 2 is negative 6, plus 4y is equal to 6. We'll continue adding 6 to both sides. 4y is equal to 12. And wrap up by dividing both sides by 4. So y is equal to 3. So my final solution, as an ordered pair, always as an ordered pair, should be my x coordinate of negative 2 and my y coordinate of 3. And if I quickly go back and verify the accuracy of that solution, I can do some quick mental math and verify both equations are true. So 3 times negative 2 is negative 6. 4 times 3 is 12. Negative 6 plus 12 is equal to 6, as the top equation should be. And in the bottom, 5 times negative 2 is negative 10. 2 times 3 is 6, and negative 10 plus 6 is negative 4, as the bottom equation should be. So there is your extension to using elimination, but by way of multiplying one or both equations as needed to force your coefficients for x or y to be the same or opposite so that you can continue with the adding or subtracting of the equations as you've previously explored. So that is closing out our discussion with solving linear systems of equations, and we'll continue with our practice.